Hello, welcome to Python Interview Hacks. Let's see our problem statement. Given an m by n grid of characters board and a string word, return true if word exists in the grid. The word can be constructed from the letters of sequentially adjacent cells, where adjacent cells horizontally or vertically neighboring. The single letter cell may not be used more than once. So let's understand our problem first. So here we have a matrix A, B, C, E, S, F, C, S, A, D, E, E. So here in this board we have to find this string A, B, C, C, E, D. If this string is present, then we will return true. If not, we will return false. So these are the some rules we have to follow. As we have seen here in the problem statement, the cells has to be adjacent horizontally or vertically. So here you can see first word we found A and B is adjacent horizontally, C is adjacent horizontally. Here the next letter C is adjacent vertically, same with E, vertically adjacent, and D is horizontally adjacent. Again, one more condition we have to keep in mind, that single letter cell may not be used more than once. So here we are finding C. There are two C's here in our string. So here we cannot visit this C again. We will have to go to the next cell only. We cannot visit any of the cells we have already visited. So let's see. So the first letter in our string is A. So we will go through the row. So we are finding this first letter A in first row, first column. So A has been added. Next letter we are finding for is B. So we cannot visit the same cell in the path. So A is not in the option. So we will see vertically and horizontally. So upwards we don't have anything as we are in the first row. In the second row downwards, the letter we found is S, which is not equal to our letter we want to find. So this is cancelled. So we will go horizontally again. On the right side, we find the letter B, which is equal to the letter which we are looking for. So this has been added to our path. Next letter we want to find is C. So again, we will look horizontally and vertically. So we cannot go backward as we have already visited this cell. We have already visited this cell also. So we will go upward, downwards and sideways. So upwards we don't have anything as this is our first row. Downwards we found the letter in the same column, that is F, which is not equals to the letter we want to find. But in the sideways horizontally we found the letter C, which is equal to the letter we want to find. So this has been added. Next letter we have again C. So we have C here, but we cannot visit this cell again. So again we will look horizontally and vertically. So when we look horizontally, we find the letter E. So now this letter is not equals to the letter we want to find. Then we went upwards. So again we cannot find anything as this is the first row. Downwards we found the letter we were looking for, C again. So this has been added to our path. Next letter we want to find out is E. Again we are going to look horizontally and vertically. So we cannot look up as we have already visited this path. Sideways we found the letter F and S, which are not equal to the letter we want to find. But at the downwards in the next row, same column, we found the letter E. So this has been added to our path. Next letter we are looking for is D. So again we are going to look for the letter D in horizontally and vertically. So again we cannot visit as we have already visited this path. On the right hand side we find the letter E, which is not equal to the letter we want to find. Downwards we don't have any rows remaining. On the left side we found a letter that is equal to the letter we want to find. So here we have completed our path and we have found the string we were looking for in our matrix. So we will return true. So let's see how we can solve this using Python. So here we are defining a function named search and we are passing the parameters list1 and word. So this will be our matrix and this will be the string we are looking for in our matrix or board. So row, to get the total number of rows present in our matrix, and calls to get the total number of columns present in our matrix. So row equals to length of list 1 and calls equals to, we will basically count the elements present in first row. So length of list 1 0, and that's how we will get the total number of columns. So again we want to save the path. So path equals to set to add current values at the board, and we are using set here because set accepts only unique values. So we want to look for the word in both horizontally and vertically. So across our board, so we will be using depth first search here. So we are defining a function named depth first search and we are passing RCI. R is for row, C for column, and I is for current character. Now if I is equals to length of word, means if the current word is the last word in the string, then we will return true. So for example here D, this word was the last word in the string and means we have completed the whole string and this is the last word, then we will return true. Now if R is less than 0 or C is less than 0, which means if the rows and columns are out of bound, then we will return false, or row greater than or equals to R greater than or equals to row, or C greater than or equals to false. Again in that condition we will return false, or word of I not equals to list 1 of R C, which means what if the character we are at in our word is not equal to the character we are at on our list or matrix, means if we find the wrong character here, again then we will return false. So for example here we found E here which was not present in our string, so we will return false. Or the last condition is RC in path, which means the row column position we are at is inside our path, means if we are revisiting the same position twice, in that condition also we will return false here. And lastly we will add the path, the path we have already visited to this path variable. So path dot add row column. So now we want to look through all the rows and columns. So we will be using recursive function here and we are going to call this function depth first search again. So res equals to depth first search r plus 1 c and I plus 1, means we will increment the row by 1 and leave the column as it is, and if we find the word, we will add 1 to I because we found the character we are looking for. The next condition is R minus 1 C I plus 1, means row minus 1 and leave the column as it is. We will look up in the row or down in the row and column will be the same, and I plus 1 if we found the character. The next condition is leave the row as it is and column plus 1, means row will be as it is and we will look column plus 1, means we will look at the right side of the column, and if we found the word then I plus 1. The next is leave the column as it is and column minus 1, means we will look at the left hand side of the present cell and if we find the word then I plus 1. And lastly path dot remove r comma c, means we don't want to visit that again, so we will remove that path, row and column, and finally we will return the result. So now we will have to go through every single position in our row and column. Okay, so row and column, every single position, so that's why we are going to use for loop for r in range of row and for c in range of columns. So we are making sure that we are visiting every single position. If depth first search, so now we are finally calling this function here. If depth first search and we are passing RC and 0. So running depth first search rows, column and 0 0 for position of I. So we are starting with 0 row, 0 column. And if this is true, means if we are finding the characters, we are finding the whole string here, then we will return true. And if we did not find the character we were looking for, then we will return false. So let's run this program. So here I have taken a matrix, the same matrix we have seen in the example above, A, B, C, E, S, F, C, S, A, D, E, E, and the string we are looking for is A, B, C, C, E, D. So if I run this, I will get the answer as true here. Now if I change this string like this, if I remove one C here, I will get the answer as false. So here we are at the string A, B, C. So we have found till here. So next letter we will go to the right hand side. We will increment column by 1 and I will find the letter E here, which is correct. But the next letter we want to find is D here. So I will look upwards, so nothing is there. I will look horizontally, nothing here. Downwards, we found the wrong character, that is S. And now we cannot visit again this previous position. So again, we cannot find D here. So that's why we are getting the answer as false here. So this is how you can look for a string in a matrix or a board. If you like this video, give it a thumbs up and make sure to subscribe to our YouTube channel.